All right, so the first thing we're going to do is review. Reviewing what we looked at yesterday. That way, if you did not watch the video, you'll be okay to play catch up today. But you will need to go back and finish the homework guides and notes from yesterday. So, for today, we're going to solve each system by graphing. Last week, we solved algebraically. On Thursday, we looked at two equations and determined the number and type of solution and classified our equations. We followed up with that on Friday. Yesterday, you were supposed to have completed the quizzes by submitting your answers to the packet you did in class on Friday, and then copying down the notes for the 4 examples from yesterday and working on the homework. Today, we're going to look at graphing on the calculator with linear systems. That's good. And in order to do that, we're going to start by looking at examples. So in example number 1, you have two equations. What we want to do to start is set both of those equations equal to y. So solve for equation 1 by setting them and solving for y. Good old Charters Houston Wi-Fi. Okay, let's do this. So in example 1, solving for y, we get 3y equals negative x plus 2. Divide everything by 3, and we get y equals negative 1/3 x plus 2/3. And in the second equation, we have 3y equals negative 3x minus 6. Dividing everything by 3, we get negative x minus 2. So if we start with graphing that second equation, it goes through negative 2 and has a slope of negative 1. If we graph the first equation, because it has a y-intercept of 2/3, I might try to plug in a number or try to find a different value. So this is called my y-intercept. So maybe I want to go about finding the x-intercept. Mrs. McBride? Hey. Of who? Oh, sorry. No. No. You're welcome. Bye. Alright, so if we find the x-intercept, that occurs when y is 0. So you get x equals 2 when y is 0. So we could plot the point 2, 0, and then use our slope from there. So instead of trying to use the y-intercept, I can use the x-intercept, which will allow me to graph a much more prettier equation. So you have 2, 0, a slope of negative 1/3, and we see that the two graphs do in fact intersect, and their point of intersection occurs right here at negative 4, 2. So that is our solution. These are intersecting lines. which means they have one solution and the system is independent. Graphing equations for 2. Solving for y, you get negative 2x plus 5. So starting with your y-intercept, applying our slope, then doing the same for the second equation. So adding x to the other side, starting at my y-intercept and applying my slope. Once the two lines intersect, I kind of stop drawing in my dots because that tells me where my solution is. So the solution to this system is once again that point of intersection. So it's at 1, 3. And that's my solution. The solution is the point of intersection. In this case, at 1, 3. Okay. So for the next part, what we need to do is look at our graphs on a graphing calculator. So we are going to take out our graphic calculators. So go ahead, and I'm going to do mine on my graphing calculator. Go to on. Hit second quit to get you to that home frame. And then what you need to do is click Stat. We're going to go to Edit. And hopefully your edits are blank. If they are not, that's okay. You can actually type on top of the data that's in there. So again, if they're not blank, that's okay. You can type on top of the data that's in there. So we're going to enter the data from that table and that example. So you're going to enter in the data here. So L1 will be my week, and L2 we're going to start with ed. So once you've entered in your data, you go to Stat, go to Calc, go to Option 4 for Lin Reg. Yours, you don't have to hit Calculate, you just hit Enter. And it should give you an A and a B value. It should give you an A and a B value. So A represents the slope and B represents the y-intercept for ed. So down here, X is number of weeks, Y is pairs of shoes. Ed is equal to Y equal 5.9 X plus 44. So ed is Y equals 5.9 X plus 44. Then you're going to go back. You're going to hit Stat. You're going to go to Edit. And now we're going to change Ed's numbers to Joe. So just type right on top 40, 47, 56, and 62. Go to Stat, go to Calculate, and back to option number 4. So now you get a new A value and a new B value. So that represents Joe. So Joe is 7.5x plus 32.5. So it says use the graphs of the models to predict the week in which they could sell the same number of pairs of shoes. So we're going to go to our graphing calculator and we're going to enter those equations in. So you have 7.5x plus 32.5. For Joe. And then you're going to enter Ed into the other spot. So you have 5.9x. The X key is right here on the calculator. So you're going to use this button right here for X. And then you put your y-intercept of 44. So identifying with my data, my X values are the weeks. So that's 1, 2, 3, 4. So my window for my X min, we're going to change it to 0. Because you're never going to have negative time. And then my Y values, well, they're never going to sell negative shoes. And it looks like the least number sold was 40. So I'll make my Y min 40. And my Y max, I'm going to take out to 100. Because I don't know when they're going to sell the same number. Then I hit graph. So this represents Joe. This represents Ed. So what I want to know is, where do they meet? So you're going to go to second. This button here called trace. And what you'll notice is the word intersect. So we're going to go down to 5. I'm going to move my flashing cursor to about where they hit each other. And I'm going to hit enter 3 times. And I see that they intersect in week 7 at 86 pairs of shoes. So it says use the graph to predict the week in which they could sell the same number. So at week 7, they sell 86 shoes each. So in week 7, they both sell 86 shoes. Let's look at example 4. So again, X represents the number of years since 1968. Y represents the winning time in seconds. Now you have to be careful because I stated that it's the number of years since 1968, which means we're not actually typing in the years. We're typing the numbers of years since then. So 1968 is 0 years from 1968. 1972 is 4 years. 76 is 8 years. 80 would be 12. 84 is 16. 88 is 20. 92 is 24. If you didn't notice the pattern, we're increasing by 4. 96 is 28, and the reason you're increasing by 4 is because the Olympics occur every 4 years, and this data relates to the Olympics. So we're going to go to our calculator again, hit Stat, go to Edit, and then you're going to type in 0, 4, 8, again we're going by 4s, 16, 20, 24, 28, all the way to 32. Make sure you arrow all the way back to the top for L2 and match up the times for year 0. So we start with the men's. So that's 43.86, 44.66, and then just keep going down. Your last data should match up in each, so 32 should be 43.84. Then go back to Stat, over to Calc, and option 4. And get our equation. So you get y equals negative 0.024. We like to stick to 3 decimals when they're long. X plus 44.428. And then we have to go back and do this for y. And putting in the women's times now, starting back at 0. 52.03, and so on. Go to Stat, Calc, 4, get your equation, and you get y equals negative 0.088x plus 50.860. It says, assuming these trends continue, predict the year in which the women's times could equal that of the men's. We call this a break-even point. Businesses often use this point to find when incomes equal costs. So in our case, we're going to go back to y equals. We're going to take out the equations that were in there before. We're going to type in these 2 new equations. So you're going to type in these to y1 and y2. No idea. Even on, it's literally on an HDMI port. Okay? So then that gives you your 2 equations. You got to go to your window and match your data. So X is years, so it's 0. We ended with 32. So we got to go beyond that, maybe to like 60. You could go by 4 since that's how often the Olympics occur. Our fastest time to our slowest time are in the 40s and 50s. So I'm going to go 30 to 60. Hitting graph. That first line's men. Second line's women because they're slower. And we can see that even after 60 years, the men and women will never be the same time. So I got to go back to my window, maybe go out to 100 years. And it kind of looks like they hit, so I might go out one step further just because I like to see clearly. Once I can see they definitely intersect, go to second, go to trace, go to 5, move your cursor, and again, you guys are going to be doing this using the calculator apps that I've set you up with for your homework due on Thursday. Hit enter 3 times. And we see that they intersect at 100 years and 42.016 seconds. So after 100 years, they both should be at 42.016 seconds. And then it says predict the winning times for the 400 meter in 2008 and 2024. So you need to know how many years from 1968 they are. So that would be like 1968 or 2008 minus 1968, which is 40 years. So you go back to your graph and you need to find out when the x value is 40. So you can go second trace, go to value, type in 40, and the men's time is 43.468. And the women's, you can actually just arrow up. So hit the arrow up or down to move between the two, and it's 47.34. Okay. So to finish this out, what I want you to do is we're going to ignore problem D. So you just put an X on that at the top of that next page. Your homework is day 3. So you're doing 23 to 31. You're doing 23 to 31. For tomorrow, I believe you have to upload yesterday and today. So for tomorrow, I believe you have to upload yesterday's and today's homework. We're going to do the 3-1 on Thursday, so don't worry about doing 3-1.